So earlier we have completed unit 5, ordinary differential equation. Now this is our last chapter, last unit, partial differential equation. So in this we are going to cover a few of the techniques, method. By using those, we will be able to calculate or solve or provide solution to partial differential equations. Okay, so before jumping on to the actual techniques or method, let's cover some fundamentals. Okay, so my voice is. So we were discussing about ordinary differential equations in the previous chapter. You have seen this is the form of a ordinary differential equation. Here you will find there are two variables x and y, out of which x is the independent variable and y is the dependent variable. Okay, so y can be written as a function of x. Now how can you identify a ordinary differential equation? By simply looking at how many independent variables are present in the differential equation. If there is only one independent variable in the equation, that means you are dealing with ordinary differential equation. But dependent variable, there might be one or more number of dependent variables. So in some of the cases you might go with dz by dx equal to d square y by dx square plus some function. Okay, so where there are two dependent variables z and y, but we are dealing with only one type of or one independent variable x. Okay, next PDEs, partial differential equation. So partial differential equations or this kind of partial derivative represent a rate of change of a function, but this function involves more than one variable. Okay, but one more than one independent variable. So for example, you might see a partial derivative represented as like this: dou u by dou x equal to some function of x, y, z, u, or dou u by dou y, or dou square u by dou x dou y. Okay, all these parameter are equal to some function of x, y, or u. Okay, now what you understand from this function, that u is a function of x and y. Okay, so that means we are dealing with x and y as an independent variable. X and y does not have any kind of direct relationship between each other. Y is not depending on x or x is not depending on y. Both are independent, but u is a function of x and y. So it depends on both of the function. So that means in partial differential equation, there are two or more number of independent variables. Okay, so your differential equation will consist of two or more independent variables, and you can have one or more number of dependent variable. Okay, instead of along with you might have omega or w, q, etc. Okay, so dependent variable भी कितने भी हो सकते हैं, but independent variable should not be one in partial differential equation, and it should be one in ordinary differential equation. Okay, by looking at number of independent variable, you can easily identify what type of differential equation you are using. Okay, now before going into the calculation or mathematical part, we should have some kind of motivation why a mechanical engineer or a engineer needs to study a partial differential equation or needs to study a solution technique of partial differential equation. Okay, so let's see one example. As a mechanical engineer, we study heat transfer, and most of the time we deal with heat conduction. Okay, so let's take an example of a heat conduction. Assume that there is one solid body, and to that solid body either heat is supplied from the external source, or due to the property, mechanical and chemical property, sorry, chemical property of this solid, the heat might get generated here. Okay, so there might be two options: heat generation or heat supply. Okay, and over the period of time, the due to the property, heat might get conducted, or some of the heat might get stored inside the solid. Okay, so this is general scenario, and we would like to get temperatures at various location. We call it technically as a temperature distribution. So we would like to, our area of interest is to find a T, temperature distribution, over this solid body. कहीं पे भी हो सकता है. Okay, the location might be different. We would like to know the temperature at this point, point number one, temperature at this point, another location. So at every location we would like to get a temperature value. Now, by applying law of conservation of energy, that means we are going to balance the energy. So rate of heat supplied plus rate of heat generated should be equal to the rate of heat leaving the system or leaving the solid element plus a rate of energy which is stored within the solid. Okay, so this is your balancing equation. Then you will apply some physical property to it. इसका mathematical model from physics, you will convert it into a mathematical equations. Okay, then you will apply some limits, x y z limits लगा दोगे, then times लगा दोगे. Put the properties like thermal conductivity etc into the equation. So after some time you will get this modified equation. Okay, which involves, see, various rate of change. Okay, so this T is the interest of us. Okay, so हम we would like to find out ये temperature कितना है at various location. Okay, now don't go into the detail कि भाई ये कैसे equation आया, ये क्या है, इसका meaning क्या है. Don't worry about. We are going to think about what are the things are involved in the partial differential equation in the heat conduction part. Okay, so by mathematics you will get this equation, and after that we are going to apply some kind of technique to solve this or to evaluate this. Okay, now why we are calling this as a partial differential equation? Now if you look at this system, look at this equation, how many variables we are playing with? See, rho, c, k, etc. These are constant values. आपका specific density हुआ, specific heat हुआ, k is the thermal conductivity, etc. So all these are constant parameters. So I'll erase this constant parameter. Now look at the variables. आपके variables देखो क्या क्या है. We are having a t, x, y, z, and t. These are your variables. Now here, this T, try to understand the physical meaning of this. T is the temperature at various location. Okay, so just imagine we are having two location. Location number one, where the temperature will be T1, and location number two, where the temperature will be T2. Now, this T1 temperature and T2 temperature, will it be same? Obviously no, because the location are different. Assume that the T1, this one location is very nearer to the heat supplied. यहाँ पे आप हीट इनपुट कर रहे हो, तो यहाँ पे ऑब्वियसली यहाँ पे टेम्परेचर थोड़ा ज्यादा होगा और T2 की जगह टेम्परेचर थोड़ा कम होगा. So what you understand from this T is a function of location. कहाँ पे आप टेम्परेचर मेजर कर रहे हो, उस पे वो टेम्परेचर T का वैल्यू चेंज होगा, राइट? सो T is a function of location. Now location, how you define a location? With x, y, z coordinates, right? So T is a function of x comma y comma z. Now second thing, just see the scenario. हमने क्या किया? After supplying the heat and आफ्टर कंप्लीटिंग 10 सेकंड हमने T1 और T2 टेम्परेचर मेजर किया. ओके, देन आफ्टर सम टाइम्स हमने ये जो हीट सप्लाइड था वो क्लोज कर दिया. एंड आफ्टर 1 मिनट अगेन विद द सेम लोकेशन, location number 1 and location number 2, we have measured the temperature. So that means earlier temperature and temperature after 1 minute are obviously different. ठीक है, कंडक्शन के वजह से टेम्परेचर थोड़ा कम हो जाएगा, राइट? कूलिंग इफेक्ट होगा वहां पे. सो दिस टेम्परेचर is also a function of time when you are going to measure the temperature. So your T is a function of temperature, is a function of location and time. We call it as a space and time domain. Your temperature is a function of space and time. Space represented by location xyz coordinates and time by t. So understood this. Now why we called it as a partial differentiation? So whenever you calculate any rate of change, you are calculating with respect to x or with respect to y or with respect to z or with respect to t. So when I differentiate this t with respect to only single variable x. Now see, this t is a function of x, y, z and t. चारों का है, but मैं differentiate जब कर रहा हूँ, I am differentiating with respect to x. So that means we are representing only part of the derivative, part of the function. So that's why we call it as a partial differential equation. Okay, and also because there are 4 or more number of independent variable. Okay, so just some basic आपको already ये पता होगा why we call it as a partial differential equation, not the ordinary differential, because it's a part of derivative. So similarly, you will get equations for in fluid dynamics. In fluid dynamics, you will observe application of partial differential equation in heat transfer, in boundary layer flow or flow dynamics, then elasticity in mechanical property, compression, vibration, quantum mechanics, electromagnetic theory, etc. बहुत जगहों पे you will get you will come across partial differential equation. Even if look at the software as a mechanical engineer, most of the time as a CAE engineer, you are going to work with ANSYS or Abacus or some COMSOL software, then LS Dyna, etc. So बहुत सारे सॉफ्टवेयर जो वर्क होते हैं, those are governed by FEM method, finite element method, or finite difference method, and there are some software which are driven by finite volume method. Now all these method, आपने CFD भी नाम सुना होगा, CFD. All these methods somewhere they involve solution of partial differential equation. Your governing equations are partial differential equation. Like for stress tensor, you are having dou u by dou x etc. Okay, वहां पे आप strain calculate करते हो. It's like in CFD also you solve some partial differential equation. So many of the software need to be sorry, those software involve solution or implementation of the methods of solving partial differential equation. And one point you need to note here that this finite element method, finite difference method, FEM, CFD, all these are nothing but numerical methods only. These are not exact method or conventional method. These are one of the topic of numerical method. But जैसे FEM आपने देखा होगा, FEM is too popular because उसका application बहुत ही vast है. So that's why instead of that FEM becoming a topic or a chapter or unit of our syllabus, हमने क्या किया, उसको एक अलग से पूरा कोर्स लगा दिया. ठीक है, so we have a dedicated elective choice or elective subject called as a finite element method, FEM, and also CFD. Okay, and these two courses are nothing but a part of numerical methods only. Okay, so going ahead, now you understood that why we need to study this topic. So we'll proceed ahead. Uh, one point I would like to mention here, there are plenty of types of partial differential equation. Okay, like we have linear partial differential equation, non-linear, quasi-static, then homogeneous, non-homogeneous, first order, second order, third order. बहुत सारे partial differential equation के types available है. Now again we have a limited scope. We cannot cover each and every type of partial differential equation. So we need to make a decision what we need to study. So it has been observed that in most of the engineering problem, somewhere you will come across a linear and of second order partial differential equation. So instead of going through entire partial differential types of partial differential equation, uh, we will look into only linear second order equations, and that to be only two independent variables. Okay, because as soon as you increase number of variables, the complexity get increase. Now with the application of linear second order partial differential equation having only two independent variable, the general form of PDE you observe is something like this: A into dou square u by dou x square plus B into dou square u by dou x into dou y, okay, plus C into dou square u by dou y square plus D equal to 0. Okay, now in this the independent variables are x and y, dependent variable is u. A, B, C are some kind of function of x comma y comma u, and this D might be some function of x comma y comma u comma first order derivative of u with respect to x, or it might be consist of dou u by dou y, first order derivative partial derivative of u with respect to y. Okay, ऐसे कुछ तो भी consist हो सकता है. Another thing I would like to highlight here, in some of the example you will get a equation represented as u x x like this. Okay, so if you remember your normal differentiation dy by dx is represented as y dash, or if you are dealing with second order derivative, you represented in a short form like y double dash or y double prime. So similarly to represent partial derivative. For example, dou u by dou x. To represent this partial derivative, it is represented like this small letter u and suffix x. So इसका meaning क्या है? Dou u by dou x. And if you are having second order partial differentiation, तो आप क्या कर सकते हो? You can represent it as u x x. Here, this you will represent as small u suffix x and y, and this represented as y, sorry, u y y. Now why I have told you, because in your examination we might provide the example or equation in a short form instead of writing dou all the time. Now this is your general form of. So I was talking about a general form of equation. आपका ऐसा कुछ तो भी typical equation रहेगा. Okay, and also I recommend you to remember this general form. Okay, so a into आपका डबल पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू एक्स, और यहाँ पे है b इंटू एक्स इंटू वाई. रिमेंबर दिस, ये सीक्वेंस भी ऐसे ही आपको याद रखना है. एंड डबल डेरिवेटिव पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू y. Okay. Now in this equation consists of a, b, c and d, where a is a function, sorry, a, b, c are the function of x and y, and d is a function of x, y, u, dou u by dou x and dou u by dou y. So this part was covered earlier. Now further, this general form are classified in three categories. Okay, and these three categories are created using method of characteristics. Don't worry about it, बाद में I'll explain this. And why we are converting this equation, or why we are classifying this equation into three different categories. First, understand that based on the category, there is a specific or a distinct engineering application. Okay, एक specific application के लिए एक specific category है, and corresponding to that particular specific category, there are specific techniques which we need to implement. Okay, so understand this. We are going to have three categories, three types, or three classification of this equation into three categories. Based on the each category, there is a specific application and specific method. ठीक है, तो वो मेथड इंप्लीमेंट करके ही वो उस टाइप का आप प्रॉब्लम सॉल्व कर सकते हो. ओके, नाउ फर्स्ट थिंग we will look at how we can characterize or categorize this equation. So assume this is our general form of a partial differential equation of linear and of second order. Okay, now calculate, for given equation, calculate b square minus 4 times ac. इसको आपको क्या करना है? न्यूमेरिकली कैलकुलेट करना है. एंड वॉट एवर आंसर यू विल गेट, compare that answer. Now there are three possibilities. Either whatever answer you are going to get, it might be less than 0, it might be greater than 0, or equal to 0. Okay, so आप क्या करोगे? compute करोगे, and based on that, if this value is less than 0, we call it as a elliptic equation. If this formulation, this equation gives you equal to 0, इस इक्वेशन का आपने अगर b square minus 4ac कैलकुलेट किया and you obtain a value equal to 0, we will treat that equation as a parabolic equation. If the value of b square minus 4ac comes greater than 0, we call it as a hyperbolic equation. ठीक है, अब तक जस्ट फोकस ऑन दिस कि भाई ये बी स्क्वायर माइनस 4 टाइम्स ए सी अगर आपने कैलकुलेट किया, अगर लेस देन 0 आया तो इलिप्टिक इक्वेशन, इक्वल टू 0 आया तो पैराबोलिक इक्वेशन, एंड ग्रेटर आया तो हाइपरबोलिक इक्वेशन. ये नोट कर लो, नोट डाउन दिस पार्ट. I instruct all students to please note down this equation, general form, and the half of the table. Or if you want, you can take the screenshot of this. Don't get confused. I'll make it very clear. एक एक चीज fully explain करूंगा. Now, if you divide the equation, or if you identify what category of equation you are handling, based on that you can implement a typical technique. See, to solve the equation of elliptic category, there are some set of steps which you need to follow. They are different from the method or technique which you follow for parabolic equation. सबके लिए प्रोसीजर जो है वो अलग अलग है. So that's why it is very essential to identify कि आपका जो भी प्रॉब्लम स्टेटमेंट होगा, that problem statement belongs to which type of category. ठीक है, इन तीनों में से कौन सा तो भी एक का होगा डेफिनेटली, एंड आपको वो आइडेंटिफाई करना है. हाउ यू आर गोइंग टू आइडेंटिफाई? यूजिंग कैलकुलेटिंग दिस बी स्क्वायर माइनस 4ac. Okay, next thing I'll explain about the example. If you look at the two-dimensional heat conduction, फॉर एग्जाम्पल आप एनालिसिस कर रहे हो प्लेट का. ठीक है, एक प्लेट है, आपने हीट सप्लाई किया है उसको, एंड यू वुड लाइक टू गेट अ टेम्परेचर ग्रेडियंट और हीट फ्लक्स. रिमेंबर, इट्स अ 2D प्रॉब्लम, एक्स एंड वाई, एंड इट्स एज्यूम दैट प्लेट है तो निग्लिजिबल थिकनेस. So if you are analyzing this kind of problem, here your interest is to get a temperature gradient, temperature distribution, not over the period of time. If you are dealing with only two independent parameter, and that to be correspond to space element or space domain, that is x and y. Okay, that means you are selecting elliptic category. Obviously your b square minus 4ac will be less than 0. Okay, or you can go other way around. If your equation gives you elliptic category, you can implement a technique of a solution for Laplace equation, because Laplace equation is like this. आपने देखा होगा कहीं पे डाउ स्क्वायर टी बाय डाउ एक्स स्क्वायर प्लस डाउ स्क्वायर टी बाय डाउ वाई स्क्वायर. Here there are only two independent parameters x and y, and both are of space domain. Okay, so in next lecture I am going to explain, or I am going to show you procedure by which you are going to solve Laplace equation or elliptical equation. ठीक है, now sometimes if you go for parabola, उसका example है देखो, heat conduction, again heat conduction, but heat conduction with only one space domain variable and one time domain variable. For example, इसका example बताता हूँ. You might have seen pin fin analysis or pin. assume करो एक pin है, एक पिन है, and it is insulated laterally, and there is heat supplied like this, and you would like to know temperature at various location only in x direction, because heat is insulated in this direction, so no heat transfer in y direction, so your interest will be in x direction only. But at various time, different time में कितना temperature होगा? Okay, so that equation consists of two variables x and t, one from space domain, one from time domain. Okay, तो इसका जो procedure होगा, right, so it belongs to parabolic category, and we have to follow some different steps to solve this kind of equation. Okay, also if you look at the vibration analysis, for example आपने क्या किया, एक string लिया, गिटार का एक string है, पूरा full tight कर लिया उसको, and then you apply some amplitude to it, उसको hit कर दिया, so what will happen, it will try to vibrate like this, and that is in, assume that this is x direction and at particular time. So wave equation, it is a little bit different than the heat conduction equation. Okay, so this kind of equation can be solved with the technique of solving hyperbolic equation of partial PD. तो इसका अलग कैटेगरी होगा, उसका अलग टेक्निक होगा. So one by one we will tackle each one. We'll start with Laplace equation, but before that मैंने बताया था कि it is very essential और important to identify कि भाई कौन से, ये तीनों में से कौन सी मेथड आपको अडॉप्ट करनी है, कौन से मेथड से सॉल्व करना है. ओके, तो पहले वही प्रॉब्लम पार्ट कवर कर लेते कि भाई हाउ टू आइडेंटिफाई इक्वेशन. सो लेट्स गो इनटू दोज डिटेल, एंड प्लीज मेक अ नोट ऑफ दिस. आपका जो एंड सेमेस्टर एग्जामिनेशन होगा, इन दैट देयर विल बी सम क्वेश्चंस ऑन 1 मार्क्स एंड 2 मार्क्स. सो टिपिकली वी आर गोइंग टू आस्क क्वेश्चन लाइक दिस कि भाई क्लासिफाई इक्वेशन, कि भाई ये इलिप्टिकल इक्वेशन है, पैराबोलिक इक्वेशन है, या hyperbolic equation. We can easily ask a question for 1 mass. Okay, so we can solve this. First we need to compare this equation with our general form. I know it is very easy to solve, but for some student I'll explain in detail each step. So क्या करो, जो भी आपका equation आया ना, compare that equation with our general form. So that's why I made you to write down or take a screenshot of general form of partial differential equation. So compare these two equations, and what we need to evaluate to classify the equation, judge करने के लिए अपना हमें क्या चाहिए, solution of b square minus 4 times ac. ओके, तो आइडेंटिफाई कि भाई b कितना है. चलो b कितना है, देखो b is the coefficient of dou square u divided by dou x dou y. Go into your equation, look at this dou square u dou x dou y. So उसका coefficient कितना है, 4. So that means b is 4 square minus 4a. Compare this a dou u dou square u divided by dou x square. इसका coefficient कितना है, 1. So 1 into c. C coefficient is of dou square u by dou y square, which is 4. Right? So इसका आंसर कितना आया, 0. Right? And 0 is nothing but a parabolic equation. मतलब अगर आपको ये solution, इसका problem solve करना होगा, you need to implement methodology or technique used for parabolic equation. उसके steps आपको follow करने हैं. ठीक है, I guess some of you have answered correct. Nazar, it's a parabolic equation, right? So similarly, try the next numerical. ये आप try करके देखो. Again, it's a simple one. I'll send you a link to record today's attendance and answer of this numerical. Okay, so most of you have solved this numerical and you might have obtained that uh, the equation is hyperbolic. Okay, so I'll go ahead with the one more numerical. ये थोड़ा अलग है. Now read the problem statement. Uh, the question is classify the equation. We need to judge is it a parabolic equation, elliptic equation, or hyperbolic. Okay. Now, if you look at this and compare it with our general form, what we have, the value of A, B, and C. See, B is not available in the equation, so that's why B is equal to 0, A is equal to x square, and C is equal to 1 minus y square. Now, if we put those values in B square minus 4AC and solve it, you will come across this 4x square parenthesis y square minus 1. Now, based on this data, we need to judge कि भाई ये elliptical है, parabolic है, hyperbolic है. Now, to judge this, to calculate, to further evaluate this, the limits are given for x and y parameters. X, if you look at the x value varies from minus infinity to plus infinity. And in our equation, we are dealing with x square. So even if the x value might be negative or positive, the x square will be always positive. So this first term 4 into x square is positive term. Now look at the parenthesis or term in the bracket, y square minus 1. Okay, now y is varying from negative 1 to positive 1. It might be in between this. It should be less than positive 1. मतलब इसका मैक्सिमम वैल्यू कितना हो सकता है? It will be 0.9999, right? Okay, so y का maximum possible value will be 0.9999 etc. or less than that, towards the minus 1 also. Okay, so if you take the square of it, obviously even though if you take a square of this, it will be less than 1. Y square will be always less than 1. That means if you look at this term in the bracket, y square minus 1, so y square will be always less than 1 minus 1. So what you are going to get? You are going to get the value in negative. So this part is negative. The first part, multiplication part, is positive. So positive into negative, you will get the answer always negative. And what negative means is a elliptic equation. If b square minus 4ac, right now we have concluded that this term is going to be negative. So negative means less than 0, and less than 0 means it's a elliptic. Okay, so I hope all of you understood this and there are no queries. If you are facing any kind of difficulty or queries, please let me know. And we will wait here, we'll stop here. In the next class, we are going to start solution of Laplace equation. And I urge all of you to please attend that lecture. I have tried to make it very simple. The procedure is little bit simpler than if you follow any book. Okay, so thank you guys. If there are any queries, I'll answer that. Gajanan, please wait. I'll answer that. And remaining student, you can leave the session.